All right. Thanks everybody for joining me for a recap of how that hackathon went in San Diego. Had an awesome time, learned a lot, met some cool people. Yeah, it was just an awesome experience, and yeah, I want to share how it went. So let's dig in. Okay, so it all started, I was like scrolling Twitter one night before bed, you know, looking at memes, just see what's going on the internet. And I stumbled across, oops, did I pause it? Yeah. I stumbled across a post from George Hotz hosting an elite 20-person hackathon on September 29th weekend. I'm like, oh, wow, elite. Okay, like I know the company, Comma AI. I know George. You know, like, are they going to accept me into this elite 20? Like, do I classify as elite? I don't know, man. But you know what? Who knows? I'm just gonna I'm gonna apply. I'm gonna you know, try and sell myself in the application and see what happens. So, you know, throw in an application and just see what happens. Oh, I heard a ping. What's going on? I can't see right now.
To make the joke. Sorry.
Oh, okay.
But since you started with Twitter and the first notification was about Mount Helens blowing up, it's like, I thought you were going to start with, it all started with ancient Greece. And like,
one of those. Yeah, no. So yeah, so Comma AI. So who is Comma AI? What's Comma AI? So they're this company that makes this hardware here, this self-driving car hardware. They also make the software that runs on it. So it's basically like a phone that you mount on your computer or that you mount in your car, and you plug into your car's what's called CAN bus. And the CAN bus is how the car, all devices and sensors in the car communicate with one another. And you plug into that, and it turns any car, well, any modern car, I should say, into a self-driving car. And they're trying to be like the Android of full self-driving, you know, whereas, you know, Tesla is like the iPhone of full self-driving, and we're their Android. It's fully open source. You can fork it. You can see everything that's going on in the code. And, you know, they're doing well. They're second best in the world, next to Tesla. And number 3 isn't even close to what they can do in terms of like user experience and, you know, how many, you know, all the metrics that you want to know when it comes to self-driving. They say they're about a year behind Tesla. But, you know, with some of their features and their interface, you could even say that they're on par or better. So like, for example, when it comes to full self-driving on a Tesla, you need to be giving torque to the steering wheel to tell it that you're still engaged, or else it hands control over to you. Whereas with the Comma device, it doesn't use torque sensing. It uses a driver monitoring camera to look at you to make sure that you're focused on the road, and that's how it knows. So, you know, for example, if you're making a turn, it always felt unnatural to me to like apply torque to the wheel. Like, I want the car to drive. I don't want to be driving. So with the Comma device, you can just be focused, and it knows you're focused. And so, and yeah, so it lets you go. So yeah, so that is Comma. And so yeah, so then what happened? So then I got an email, man, you're invited. I'm like, well, this is exciting, dude. Okay, cool. Robot hackathon. I got to be in San Diego. You know, they're going to feed us. That's nice. And, you know, they give you, and then on this link here, they give you some stuff to get started, like a little primer on what to do. So now it's like, okay, well, I got to go. All right. This seems too cool. The catch is that I don't know anything about computer vision. I don't know anything about self-driving, you know. So what do you do when you're in this situation? So of course I turned to my buddy Aaron, who's PhD in computer vision, engineering prof at the U while I was physics prof. He ran a vision team at ClearPath Robotics for years. All right, this is the Oracle. So I turned, Aaron, please help guide me on my path.
Bro.
And Aaron says, listen, Mike, my days of self-driving cars are over. I can't go with you. You're going to have to go this one alone. I was like, oh, man. Okay, so I couldn't recruit Aaron to my team, but he was with me in spirit, so much so that he actually gave a talk. He's like, I'll give you a talk, Mike, on computer vision to prime you and get you started. So this is the genesis of the talk that Aaron gave on computer vision. a couple months back, and it was great talk. There were new terms that I've never heard in that talk, like SLAM, OpenCV, OpenMV, visual odometry, optical flow. This stuff was all new to me. So it was a great primer, but it turned out I had some learning to do. So I turned to what they recommend in their email. They're like, take a look at our repo. And inside the repo was this calibration challenge. And so it's a game. So what do we got here? Your goal is to predict the direction of travel in camera frame from this provided video. So it's like, okay, so what did they give me? So they give you these videos, and it's like, I have to, from this video, work out what is the angle of travel of the camera in each frame. So like how offset you are from center. And it's like, okay, well, where the hell do I begin with this? And so yeah, this is where I'm at. Like, where do I begin? And so, the internet's awesome nowadays. It's time to hit the books, go online. Stack Overflow of course has got answers. You got questions, they got answers. There's some guys got full YouTube channels, things. There's textbooks online, of course. I appropriated a couple of those with PDFs. There was a Berkeley course where all the courseware was online, so I could dig into some lectures. There's like video lectures, which is helpful most of the time, but sometimes it's just like, what are you talking about, bro? And then there was good repos out there where people did some visual odometry in public, and so I could take a look at that. And then there was just random white papers, and those helped too. And so collecting all those resources, it was time to try this calibration challenge. So I'll show you how far I got with the calibration challenge. So yeah, so when you run the video, so this is an example video that I'm processing. You're processing every frame, and you're looking from one frame to the next. How did I change? What was my angle? And so how do you work that out? And then when it's all done, we plot the distance that the car went on the ground. So the blue dots is like the ground path that they call it the ground truth, because this is like, they have a way of determining with what's called SLAM algorithm. So a simultaneous location and mapping algorithm, based on 2 cameras with LiDAR and all this stuff. They can tell you exactly where they are on the ground. And then the green is my prediction of where I was on the ground versus what the actual ground truth was. And then you can map the error in that over time. And so, good to start, and then it like falling away. And of course, what you want to do is minimize error. You want to be as close to the ground truth as possible. So, so I'm getting some of these algorithms, but then like, how do you see what's going on? So the first thing I did is I drew lines, So like I can run the algorithm, but how do I know how to improve it? How do I get the error down? So what this algorithm is doing is, from every frame to the next, you're finding points. So keyframes you're finding key points from one frame to the next. So let's say this is on the top is frame 10, then this is frame 11. And if you look at, like, for example, this orange point here on frame 10, and then on frame 11, it's moved to here. So you have, and you're doing this for the entire thing. And there's, of course, some points that are good and some points are bad. You have to figure out, well, what are the good points? How do I filter out the good points, filter out the bad? So this is just my first attempt without actually like optimizing too hard. So the first thing I did was draw it so I can see what's going on. Now, if I'm going to extend this further, what I would want to do is, for example, do like a detection on this car. So like, I don't want to detect how I'm changing relative to the car. I want to detect how I'm changing relative to the ground, because the car could be moving close to me, further away from me. So I want to throw out anything to do with a moving object. So cars should be thrown out. Now, you could make the argument that maybe these trees on the horizon here should also be thrown out, because trees can sway in the wind a bunch. But I'd actually have to run the numbers to find out, because, like, they're so far away that you probably want that. And you can see the edge detection. It's doing really good at edge detection on those trees. So you can really easily map from one point to the next. And Another thing I want to do, and you can see where the error really starts to pick up toward the end here. So toward the end of the video, yeah, toward the end of the video, if you look to the right here, all these are just all over the place. So I'm clearly moving straight. So I'd expect lines to be similar to like what I'm seeing on the road here, like, to be straight, you know. But then these are like, you know, I'm going left, I'm going up, down. So I implement some sort of algorithm that, like, if you disagree super wildly with your closest neighbors, then just throw those out, because those are just adding error to the calculation. So this is visual odometry, and this is the result that I get. You know, like I said, we get this error as a function of what frame I'm at, and the goal is to minimize. And so, like, this is already, I'm impressed. Like, okay, so the way that they're getting me into this is to, like, you know, it's a challenge, it's a game. Play this game, and you know, and you'll learn about this stuff, and it'll prepare you for the hackathon. So I'm like, cool, I love games. And the next game, another thing that's in here is a CTF. A CTF is a capture the flag. And so, you know, this is another, it's a game, man. It's like all the flags are contained here. There's 2 flags in each segment. Grep is your friend. Have fun. You know, here's how you get started. And this is just basically a primer. This is really just a primer on, like, check out all the tools that we have in our, you know, in our code. So I'm going to bring up this one. So for example, one of the tools they have is that you can actually run the software that runs on the comma. You can run it on your computer. So you can simulate like you're actually running this thing right now. So yeah, so I got the comma. So I'm running the comma, and then in one terminal you run the comma, and then in another terminal you actually run a replay. So what this is doing is actually like stimulating to the cameras of the simulated comma the video that's playing. So the comma device thinks it's actually on the road driving a car right now. And so you're playing the video, you're running the logs, and this is how they, you know, this is how you dig into their code base, you know. So like I'm running this on here right now. The replay is going in one terminal, whereas another terminal, I'm actually watching it. You know, another piece of tooling they have is you can, you know, with a running stream, you can look at all the different cameras. So the comma device has 3 cameras. It has a front-facing camera. It has 2 front-facing cameras. One is a super wide angle, and one is like a more narrow angle. And the other is, like I was saying, the driver-facing camera. And so I just went full conspiracy, like, where are the flags hidden? You know, I'm like looking at all these street signs, like, oh, Washington Street, is that like a trick? You know, so I'm bringing out, you know, I'm taking screenshots everywhere I can. I'm writing everything I can down, like taking notes. I'm pouring through the logs, seeing all the different images, all the different things, trying to decode. And so playing this game, I got 5 out of the 8 flags. So there's still 3 flags that I haven't found yet. So I got to keep playing. And it was a fun experience, man. It reminded me of, like, back in the day when I was a kid, there was these like adventure games like Return to Zork or Space Quest 4, where it's like, you know, you're in like an open world and you're walking around. You got to interact with the environment. You know, you just got to figure it out. It's just like, you're in, have fun, good luck, you know, yeah, go to town. And so, yeah, is there anything else I want to share here? So that is, yeah, that was my experience with the capture the flag. So, okay, so this is all the prep work I did. And, all right, well, now it's time to, let's go and, you know, let's participate. So, you know, I show up in San Diego, I'm meeting all these people, and, you know, I show up and I'm talking to people. So I'm like, oh, what's your name? Where you're from? It's like, oh, you work at Tesla. That's awesome. Okay, great. All right. So you probably have some experience here. Oh, you're NVIDIA. You work in the robot operating system project. Wow, that's cool. Okay. So you know what you're doing. Uber, you were on the self-driving car project there. All right. Oh, you came straight from Boca Chica, working at SpaceX to do this. Okay. I'm starting to feel like, all right, I'm up against it here. Like, oh my God. Oh, you're a Googler. Oh, you're from Amazon. Like, you were a senior developer at Amazon, quit to found your own company. Okay. Oh, you work in computer vision every day. Like, that's your job. And now you're here. Okay, sweet. So this is what I'm up against. I'm like, oh man, this is I was feeling it. So anyway, now what we had to do is like, you know, we had like kind of like half an hour to an hour. They catered food, all the food was provided, and then we ate and walked around the office. So all right, let's do a tour of the office. So what do they have in the office? One of the things they have in the office is or their compound. Their office is more like a compound. It like kind of reminds me of like, I don't know, like Pablo Escobar vibes. Not that I know what that compound looks like, but kind of remind me of that. Anyway, they have what was at the time of building like around the 69th largest supercomputer in the world. At least that's like recorded and registered. I'm sure there's some supercomputers in some hidden locations that we don't know about. But theirs was up there, and they let us walk through and tour these things, take pictures, and see what's going on. You know, this thing is huge. It's got like 2.1 petabytes of solid state, 640 GPUs. Like I don't know what's the latest and greatest 4090s. There's like a stack like as tall as me of 4090s in the hallway next to this thing. Is nuts, man. Wow. So they got this monster, and what this thing does is, if you allow your common device to share your driving data, then it ends up here and it gets processed, and they use that driving data to train their models on how to get better. So the actual learning happens in this room, and then once it's like learned and taught the thing how to do its thing, the result is a model, which then gets uploaded to your common device. And if you're using a good model, then it can drive for you. And so we're going through the office, and they said we could take pictures, but I kind of felt like, all right, man, like, is this stuff you want shared? All right, like, you know. So we're looking at all their like the network infrastructure, and you know, they have like heat maps of what's going on. This thing is like a stress tester. So each of the devices, before they get shipped to customers, they get like stress tests for like a day before they actually get shipped out to make sure they're good to go. And then of course they do their all their like pick and place and circuit board printing gets all done in-house, and they got all the machinery for that, and they showed us all that. It's like, all right, cool, man. So now it's like, all right, I gotta pick a team. It's like, it kind of gave me like kind of remind me of the days of like choosing a lab partner. So, you know, in physics, my goal whenever I'm choosing a lab partner, I want someone who will just sort of let me take control. Like, a lot of people don't want someone who's just going to ride their coattails. I wanted someone who's going to ride my coattails. Like, I just leave it up to me. I'll have fun. I'll, you know, play with it. So that's like what I'm looking for in a lab partner. And, you know, I don't know if I could have found that here, but I don't know if I'd want to find that here because I have no experience. Hey, what's up, man?
Hello.
Yo, welcome to the party, dude. So yeah, so like I have like no experience. So it's like, maybe I want someone who knows what they're talking about. So I'm meeting all these people. I'm feeling super intimidated. Like I couldn't decide. I'm like, okay, are you going to help me? Am I going to slow you down? Are you going to slow me down? You know? And I was just like, I was having decision fatigue. When I finally found someone that I was like, all right, I can see myself working with you. It's like, sorry, bro, I already got teammates. And then someone else already got teammates. So it's like, by the end, everyone was sort of teamed up, and I was like, well, I'm not just going to settle, you know? So I guess I'm going to have to go to lone. I was feeling low, man. I was at my low point here. I was like, this is going to be tough, but you know what? Okay, here, I'm going to play. All right, I'm going to have fun. I'm going to go this one alone. I'm going to tinker with this robot. I'm going to come up with a plan, you know, which is like play with this thing. And then, you know, okay, I know nothing about training a model. I've never done this before, but you know, I could just like bug one of my fellow participants. Maybe they could help me. Of course, at least the people I was sitting next to were not very willing to help me out. So unfortunately, that part of the plan didn't quite work out. So that was the plan, do that. And so yeah, day one, after we get assigned our robots, it's time to get to work, man. So first step is like, okay, I just want to get familiar with the tooling. All right. They use TMUX, which is like a dual terminal setup that runs on the machine. So you can run multiple terminals, keep these terminals alive on the actual device. So that was interesting. You have to, you know, it's kind of like Vim. You got to know all these different keyboard shortcuts and all this stuff. But it's like kind of cool, the tooling they use. Cloning the repo, surprisingly, was like a tough stumbling point for a lot of us, because one of the things that sucked is like their repo is like tens of gigabytes big, and you know there's like 20 of us all trying to pull from this Wi-Fi, and just that like took hours to get working. And then of course everyone's trying to clone the repo, like heavy usage on this office Wi-Fi, and then so trying to connect to your actual robot and laglessly connect to it. Like you can connect to it, but then like, you know, if you tried to issue it a command, it wouldn't respond right away. Like that was brutal. So it's like some of us were trying to set up hotspots on our phones to connect this thing direct, so you didn't have to go through the Wi-Fi. So all this just like tooling DevOps stuff was like, it took a while, man. And then just like how to actually run the software on the device and restart the software, firmware, like get it going, make changes, you know, how to do that. So this was my goals, like just get the tooling, get the tooling going. And before bed, I was like, what I want to do is like get Hello World running on the robot, and then I'll set that as my goal. But you know, their repo was actually, it's so well written that was not too lofty of a goal. So I just set a stretch goal where get it to spin 360 degrees every 5 seconds. So every 5 seconds, I want this thing to spin, then stop, then spin, then stop. I was like, okay, I'll set that as a goal. Okay. And also I want to track my time. I want to keep track of like how it's going in here, because, you know, I don't want to just be sacrificing sleep. Sleep's important for performance. And, you know, so when the wheels start spinning, it's time to go to bed. And so that was the plan. And, you know, I'm just like head focused, getting it done. And then later that night, George Hotz. So George Hotz is the guy that founded the company. And George Hotz, so who is he? Like some people think maybe greatest hacker of all time. Maybe he was the first person to jailbreak the iPhone, first person to reverse engineer the PlayStation 3, huge open source software advocate, maybe second next to Stallman. Yeah, this guy, actually, Aaron had beef with him on Twitter. I'll let Aaron talk to you about the details on that one. Something about self-driving car safety, yeah. But I got mad respect for the guy. You know, he's competing with Tesla, which is a company of like 127,000 employees, and his shop has got, you know, 25 guys. You know, and that's what they're competing with, and they're competing, like they're not winning, like on some metrics maybe, but yeah. And you know, he's showing how fully open source software. He's showing how that can be successful in the wild. You know, like his mantra is like, yeah, you want to fork our repo? Go ahead. We'll outcompete you. You know, we'll come up with features faster than you can, better features, and we'll outcompete you. And so far, he's shown that it can be successful. And you know, I find lots of agreement with the guy in terms of you know, just like big picture, like what's the future of LLMs, like how they're gonna these large language models, how they're gonna like how we're gonna integrate them. You found the dog. Yeah, so it's like how we're gonna integrate them into our daily workflow, and like you know, his thinking is that the LLM would be a great debugger. You know, like to have a co-pilot as you're working, it'd be awesome if it could find bugs, but where it's at right now, it's not quite at that stage. So anyway, so this is George Hotz. A couple hours into the hackathon, he shows up, and actually he's working right next to me. But he's competing in that, like, he's not actually competing for a place or the prizes that were awarded. He's just, you know, he just wants to see like, hey, can I do this? Okay. And so, yeah, we're working together on the same table. I get to talk to him. He's a little helpful, but he's so zoned in. Like, I don't want to bug the guy, man. I'm just going to focus on what I'm doing. So, you know, I'm tracking my time, like I was saying, and then it's 3:30. You know, I did this one thing, and then I look at the clock, it's 4:30, and I'm still like on the same line of code, 4:30 a.m. I'm like, okay, that's it. Time to pack it in. I'm going home. And I left, but a lot of people stayed, and it's like, I think that's people need to prioritize sleep more in the hackathon. You'll perform way better, in my opinion. So anyway, so I left, and now we're on to day 2. And day 2, I wake up, I'm like, okay, what's the plan, man? Like, how am I going to have something for the next day. And so, you know, I searched to like what Zav and Alan would be telling me here, and, you know, develop an MVP, have a deliverable, something I can come up with in the allotted amount of time. And so like I went through my, like, I had like a bunch of ideas I like jotted down before I went, like, okay, turn one of these robots, make it like a friendly mode where it's like if the robot's walking down the hallway and it sees someone, it like smiles and winks, you know. Like I just remember in the hallways at the physics department at the university, it's like, you know, sometimes you walk down the hall and it's like that's exactly when a professor would find something very interesting on the wall or the ceiling, you know, as you're walking down the hall. So not a lot of eye contact and smiling. So I'm like, all right, you know, we can break this. All right, we can have a robot that like smiles and like nods at you as you're walking by. So like maybe that. And like, oh, another one is like hide and seek. Maybe I can get the robot to play hide and seek. You know, you can get it to count to 10. You can go hide, and then it tries and find you. Another one is like make it like a leopard or something. Give it like a sneak or a stalk mode where it like it'll roll up trying to find you, and then when you're looking at it, it won't move. It'll just try and hide. And then when your back is to the robot, it like tries to sneak up on you, and then maybe like play like a Rick roll when it gets close, something like that. But what I decided, like all these sounded cool, but like they were going to be really tough to deliver in the given time. So what I went with instead is I want to make a robot cameraman. So someone like who's always following you, who's got you focused in their field of view. If you go to the left, it turns to the left. If you walk away, it follows. If you get too close, it backs up. So that's like that's what I came up with. The you know, your sort of body buddy, someone that like tracks you and follows you, and you know, you can get it to take pictures for you. So I picked that MVP for my bucket of ideas. And yeah, like I was saying, face recognition for an on-device cameraman. So I wanted to recognize my face, because I don't want it to like track on to someone else. It's got to see me. And so, you know, just head down and start building this thing. And so what do we have? So what they had done is they had trained this model. This model here is called YoLo, or You Only Look Once. And it classifies different things it sees in the image in real time. And so on the device can run this thing at 20 hertz. So we can every 20 times a second, we can see what the different, you can classify the different thing. Actually, it might even be 100 hertz. I'm not sure. But so it's running constantly on the device to see, to like look at different things and then maybe go toward them. Okay. It doesn't do faces, but it does objects. And, it can tell if you're a person or a computer or a plant or all those different things. And so, yeah, so this is it running on the device. Down here, you see it's tracking. It knows that I'm a person, even though like I'm bending down face toward it. And so, so I want to get face recognition combined with this model that's like doing body detection or like person detection. And that turned out to be too tricky. So I'm like, all right, let's scale it down. Let's just do person detection. All right, let's find the biggest person in your field of view. So, every 20 times a second or 100 times a second, you're scanning, you're collecting the number of people, and, you're locking on to you're finding out which one is the biggest, and that's the one you're locked onto, and that's the one you're going to go toward. And yeah, so got it building, change scope, like I was saying. And so yeah, I had the first running prototype like midway through the afternoon, and like I wrapped this day up around 10:30. Oh, and then of course, like there's food nonstop. So people that know me know like I only eat once a day. That's like what I try to do. But yeah, when there's food, I can't turn it down, man. So like I'm sitting here, and like I'm sitting right here. I'm sort of blocking with this image. And like the buffet or whatever, the catered buffet is like right next to me. So it's like I just was like snacking almost throughout the day. Like if I worked at like a catered office, I'd be like 600 pounds, man. I just can't. If I see it, I'm gonna eat. So yeah, so we had all this food. This is like leftover from breakfast. It was like awesome spread, man. And this was just lunchtime too. Dinners were awesome. So yeah, that's what we had going on. So so now we're on to day 3. Okay, so now this is the final day. So it was a 48-hour, actually a little less than 48 hours that we had. And now I'm just like, I'm tweaking this thing. I'm trying to get it to run properly. I'm trying to optimize the parameters. So what I do at this point is like, how close do I need to be before you back up? How far away before you're going to follow? How fast, how much torque are we going to give the wheels? Of course, we're like limited into how much torque because these things are running on hoverboards and these things are very powerful. These can pull a human pretty fast. So this is what's running on these things. And so, yeah, so day 3 was just like optimize the parameters. My MVP was simple. Just track a human body, the biggest human body. That's what you're going to follow. And that gave me time to like have conversation with these guys, get to know some of these people. And like George, for example, George loves to talk, man. And, we're talking for hours about, like I was saying, like the future of AI and like LLMs and, which I just find fascinating. And it was great. And so anyway, and then the other thing is it's easy to get the device to take pictures, stream it to your computer. You do all the processing on your computer, and then you issue commands to the robot. Of course, actually, easier for most. I was running a Windows subsystem for Linux on my computer, and there was like a communication issue with the robot. So I had to run a web server on the robot and send post commands to it to actually get it to move, because the normal communication channel that everyone else was using, I couldn't use that channel. And the guys that would help me troubleshoot, well, it's like 6 p.m. on a Saturday. They're in bed or they're hanging out. So I was kind of on my own there. But yeah, so the goal was then to get it to actually run on the device. And yeah, got that going. And now let's look at some of the presentations. So, oops. Let's go look at some of these presentations.
Mike, what was the communication channel? Was it using like ROS?
I don't remember. Yeah, it was I'd have to look through the repo. I mean, these things are running ROS.
Yeah, because it's like a pub sub thing, right? So you can
exactly
send messages over the network. So if you had like a local thing that was sending that stuff out, that's how you'd normally do that.
Yeah, and I am on the same network as this thing, but then I think the port that it was listening on, you'd have to whitelist your computer's IP address, but because I'm running Windows subsystem for Linux, it's like I have the Ethernet controller for Linux that's different than the Ethernet controller for my actual machine. And so if I gave it the MAC address, or if I opened a port on the Windows subsystem from Linux side, it wouldn't open that port on the actual outside of my machine. And so it was that sucked. So but I got around it, like I said, by just running a web server on the device, sending post requests. And I never got a 500 or a 400. It always gave me a 200. So I was like, great, so it worked, and I could issue it controls that way. But of course, that's not the route I want to go. I want to run this thing actually on the device. That's the goal. So this is me giving the talk. All right, guys, thanks for joining me. Thanks for participating with me. I met a lot of cool people here. I'm having a great time. And I want to show you guys what I came up with. So this is Leon, Napoleon, as I got assigned. And we've been having a great time, me and Napoleon. He became my good buddy. He follows me around. He gives me space when I need it. He records when I need him to. And he's my companion. So I'm going to take him for a tour around the office. The way Napoleon works is he just finds the biggest person in his field of view, and he follows that person around. And so that person, is going to be me. And we're going to go for a walk. And so, okay, now what you guys might not have noticed there, there's no way you would have noticed, is, okay, so I have, when I was in grade school, I got my tooth chipped because me and some friends were like throwing rocks at each other, like for fun, we're having a good time. And so I got my tooth chipped, which sucks. But so my front teeth are like, part of them is a filling. And every like 5-ish years or so, the filling, I need to get it touched up. I need to get it replaced. And wouldn't you know it, like my freaking worst luck, right before demos, I'm biting into a slice of pizza and I bite in like in a weird way. I freaking take a chip out of my tooth. I'm like, oh my God, are you kidding me? Like right now. So I go to the bathroom, I look, I just looks atrocious. I'm like, I can't go out like this, man. This is nuts. So I'm like, I don't know what to do, man. So I'm like, well, I might as well finish this pizza. And so I bite into the pizza. I'm like, and like I bite into like what feels like a rock. And in the pizza is the chip that fell out of my tooth. But it was like full size. It like normally if a chip comes off, it's like it shatters, nothing you do. This was like a decent sized chunk. So I kind of fit it back in and it stayed in. Man. So I was so lucky, man. I got the chip back in my tooth. So I just like, okay, I set the pizza down. I like rinse my mouth out. I like rinse this thing out, got it in. I'm like, I can keep it in place. But if I do like S sounds, stuff like that, yeah, the thing comes out. So then, so now I'm presenting to all these people I don't know, live stream across the internet, like hundreds of people in the live stream. And I'm like, oh my God, like, what do I do? So I'm like, I don't want to like adjust. So I'm like trying to fix it with my tongue. And I'm gonna set them up. So this is me right now, like, and or like I turn my back to the camera. Yeah. Like, I know let's do this. But anyway, as I'm doing this, I managed to get it back in place.
While we make our way through here,
like, and you don't even know.
Try and not make yourself look big. just for this one part. The rest will be.
And I'm telling everybody, as we go through this part, just make yourself small, because what the robot is going to do, he's looking for the biggest person in his field of view. And so if you look bigger than me, it's going to follow you instead of me. So this is like I wanted to do the face recognition approach, but face recognition, I'd have to somehow get the face recognition model to actually run on the device. And I could run it in software, but I couldn't run it in hardware on the device. And if I'm running in software on the device, it wasn't
got this. Okay. We're gonna go around here. Don't be shy. Just follow me. Just ignore them. Yeah, we got this. Let's go. That's right. No. You go there. Yeah. Look at me. All right, now let's go. Great. That's what I'm talking about, guys. Eye contact. Don't even. No. Keep coming. Do not turn your head. Yeah. I know. Listen, it's me. All right. Come on. This way. Over here. Napoleon, I'm going to give you a little hand just because. There we go. All right.
I'm tiny. Look, I'm a little guy.
I'm big.
I'm little.
I'm big. Come on. Let's go, Napoleon. No.
Go this way. Come on.
I should have worn my hoodie. All right, here we go. Yeah, now we're out of the trouble zone.
Look how small I am. Hey!
Let's go. You follow me.
It was good. So we went on our little journey through the office. So the goal was to hit these checkpoints. That's the goal. They put these little X's on the ground. The robot had to hit each X as we go through the office. And so, oh yeah, right here, the chip came out again, by the way. So that was fun. So at this point right here, I'm in my head, I'm basically just trying to work this chip back in my thing. Can't quite do it. So as I make this turn out here, I wasn't even paying attention to the robot at that point. I was hoping it's working. Thankfully, the Wi-Fi cut out just as I was putting it in. So it was kind of like a stroke of luck, man. It was awesome. And so, yeah, so we got all these different checkpoints to follow. And then we're supposed to go around this landline here. And that's the end of the course. You go around the landline.
Let's go this way.
And if you do that, the course is considered over. But there's also a stretch goal anyone can actually make it. Push back a little bit. And the cameraman thought we were done here. I'm like, no. We're doing the whole loop. Follow me this way. Like, if we do the whole loop, we're going to go through. We're going to go. Because this office, like I said, is a compound. Okay? It's like a square compound. So we can do a full loop and go back to where we started if you go this way. And so, yeah, robots locked into me. course, there's a staircase. If I screw up this thing, it's going down the staircase that's right behind me. But where we yeah, you gotta go down the stairs. So I had to, and this thing's got like a threshold, so I had to get it to speed.
Almost. There you go. Good job. Can't go slow over that. You know, you always get stuck there, don't you? Almost home.
All right, a full loop.
Great. Thanks, Napoleon. Good job.
So that was my run with the robot. So that was my run. There's a couple runs I want to share with you guys. I'll try and get them to go fast because I don't want to take up too much of everyone's time. But next I'll play these guys. I thought they did a great job. And the judges agreed. So these guys, she's from Stanford. These two guys are French, I think postdocs or PhD candidates. They work in robotics, computer vision. Like this is what they do. And they came to this thing prepared. They like had a plan. They brought LiDAR equipment. They brought know-how on how to do it, and they came in like, all right, here's how we're gonna do it. And,
I'm Rian. And I'm Armand.
Yeah, and so for our model, we have a sim to real, and we train in simulation in Blender, and then use the PID trajectories to follow the line, the desired center path more closely, and then use that to train an efficient net classifier to then predict the action based on images, and then Armand, do you want to explain the...
And so what we started by doing is like mapping the office. So we used the iPhone LiDAR to get a 3D scan, and as well as the floor plan. And then from that we trained a simple PID to get some trajectories.
Yeah, I saw that. True. So yeah, that's the Blender project. We did import like basically just a quick scan with LiDAR. And then I tried to add some artificial lights that basically at the same spot of
You guys want to
real
zoom in a
lights.
little bit?
Do you want to play the keyframes?
Yeah, I'll play it. It looks like this, and there is also an animation that we made. Okay, so that's the kind of trajectories that we created. Maybe you want to explain how we created?
Yeah, just a simple PID following the line. And so then we just put those trajectories into Blender and move the camera around. And then from those images, we predict the output of the PID, which is just the steering to the robot. And that's, that's basically it.
And
do you want to show the images from...
Yeah, just the PID is like, basically we took the floor plan and we draw a path and then we tune a PID to follow it. And then using this, matching with Blender, we match like a pair of images in action and train a CNN. Yeah. Should we go for debug?
Oh, do you want to show the other images?
No, the filtering as well. It was also kind of difficult to get good trajectory using only a PID. We initially wanted to train some reinforcement learning, but it was a bit too short. And so what we ended up trying to do is, can you go to the filtering?
Was that a augmented picture? Go back.
Oh yeah, that's important. We matched the images in Blender to the images from the camera, obviously.
That's a fake. That's a simulated picture.
It's like a simulated picture, but
so it has Blender on top of the actual real image.
It's like to compare the images.
Yeah.
So we like used the camera calibration and warped the images to match the fisheye of the camera.
Yeah, and then we also have augmentations for the actual image, so like color tinting and everything. So it ends up looking really similar.
Do you have a picture of it, just a full simulated?
Maybe somewhere on the.
You know what I'm saying, right? Just the screenshot of a simulated frame with all the like matching augmentation.
Augmentation we don't have, but we
probably like the fisheye and stuff.
Yeah.
Well, this is
in the render check stuff.
Yeah, I didn't see Blender output the fisheye like realistic.
Yeah, basically, that's the issue. We do it like after Blender also, for like compute reason, because it's too slow in Blender, and also like we don't know what model they use.
Are you guys like training network purely on the Blender images, or there's a real images like mixed in?
No, just the Blender images.
And it like translates.
Yeah, pretty well, yeah.
We'll find out.
Yeah, we'll find out.
I just know.
Yeah, and
So Yeah, so with Blender, we could sample a lot more trajectories. We have 200,000 images, and we also sample along, like in different locations, kind of skewed away from the path and have it conjoined back to the path. And then we stop it. So actually, we should have had the distribution of the predicted actions, but most of the time it's predicting left and right because we don't want it to be following the path, and that's not very useful. So we stop it after a certain amount of time, and then we have it sample a different location and the PID to get a lot of different trajectories so it can recover quite well.
You want to see the demo?
Yeah.
Yeah.
Yeah,
Cool.
okay.
Yeah, they already did.
Oh.
Yeah.
Or do you want to put the...
Oh, you can turn it on.
Yeah. Do you want to put the image?
Oh yeah, can you project this? Can you project some? Yeah, okay. Okay. Yeah, we should be good to start the model.
They want to know if it's all running on the device.
Oh, I started it. Yeah, it's running
Cool.
on device with also like the team with Onyx and THNE, so running on GPU.
All right.
Pretty smooth so far.
It's pretty good.
Oh, oh, you recovered.
That was cool.
Stressful.
Oh, maybe we need to close it.
No, you can't close it. We got to deal with it.
It was closed on the simulation. Like the simulation. Whoa.
YouTube says you guys got off to a very clean start.
Yay! Let's hope it stays that way.
Yeah.
The gym seems to be the next checkpoint.
Yeah, yeah.
We have a few points.
Yeah, it's
Contention up ahead.
often tempted to go to the gym too.
I think let's hang out here because it cuts out around the bathrooms, and then if it goes around, we'll go there. Whoa!
Whoa.
Whoa!
Oh, nice.
Okay.
Whoa! It's gonna turn? No, no. So passing the X isn't bad. The X's are just checkpoints.
Oh no. Oh no, turning away.
He just wants to go back inside. All right, nice job, Spike.
Congratulations. Best one so far.
Yeah.
YouTube agrees.
YouTube agrees.
Yeah.
That was good.
Yeah, this guy's a character, man. I love this guy. He's from University of Waterloo. He is like full all in on AI, man. He is like drank the Kool-Aid, everything AI. All the code he did was written in AI, was written with, was it Codex or something?
Yeah, is it a ChatGPT dev post?
Actually, yeah. Actually, yeah, ChatGPT wrote the dev post. That's why it's like kind of nice. As you can see. Oh, you want to see where I did it? Actually, I did it right here.
Oh my gosh.
So
ChatGPT wrote the code too.
ChatGPT wrote the code. We're in cursor. All right. Yeah, it's ChatPID. I guess LLM's doing controls. It's kind of the future. I don't think you guys.
Maybe go out of that so I can see the image you showed.
Which one?
The first one. That's the most relevant one, right?
This one?
Yeah.
Yeah. So, basically, I'm doing SAM, but I guess I'm dumb and I didn't know there was a mobile version. So I'm actually running it in a A100 on modal. So that would have been nice to know if you had told me that earlier. Yeah, so PID is like $1 a second or so. Yeah, just to go through it real quick, so we run the camera, we get this image, and then we run SAM, but SAM doesn't label, so I have a heuristic labeler, which is actually the first image. That just gets floors and walls based on how big it is, and then
that's how it works.
Yeah.
Sam doesn't tell you the class.
No.
It totally tells you the class.
No, it doesn't.
It's the color. It's too
Yeah,
much.
you can.
It's the color. It's ID.
It'll give you a logic.
It doesn't tell you what it is though. It doesn't say floor.
Just do it by green or something.
That's what I did. That's what I did. Anyways, that's what I did. This is good though. So this is the floor, and then walls, and then blue is other stuff. And then we get this, and then we get a really nice ASCII image, and then we feed this ASCII into ChatGPT. So,
it's all done by cursor.
Yeah, it's all written by cursor. And the prompt's like pretty nice and beefy. Yeah, we can read some of the prompts. So, let's see. You're a self-driving model embodied as a 5-foot-tall, 2-wheeled robot. You're currently on a racetrack, and your task is to navigate. I can show you the ASCII log. So I give it this is like the floor. This is its current location. I have like a top left just so it kind of knows what's going on. And yeah, this is what it sees.
Holy shit.
You do this task as a human.
Yeah. Well, anyways, let's see what it does. I guess. Let's see what it does. So we'll see in the bottom here what it's thinking. I guess. So that's there you go. So that's from so it wants to do. Oh wait, it's okay. This should be the first one, I think.
So we're running out.
Is it using 3 or 4?
4.
GPT.
It's 4. Yeah.
This project's all about spending money in the cloud.
Okay, so we got it, ready? So W-A.
It outputs the key.
Yes, it outputs the keys on the bottom. So you can see. So that was pretty good, right? The control loop's like roughly 0.01 hertz. So it's going W. We've made it pretty far before, but
Can you guys get to explain what it's trying to do?
Yeah. Well, it says. So it makes a plan. So the plan last time was to move forward slightly, adjust to the left, stick to the left side of the track, continue to move forward, make micro adjustments.
What do? You drive down car.
Yeah, dude. So okay.
No. Can you yell at it? Can you tell it?
When GPT doesn't follow the right structure, it just goes backwards. So we got list index out of range.
Can we get it to at least recover from going into the wall? How long is that gonna take? Let's wait another 30 seconds or a minute.
I have 90 seconds.
Yes.
What is that? $90?
There's actually an A100 thinking about this problem.
Yeah, we can see it think right here. Oh my god! That's my control loop time. That's my A100 bill. And,
the numbers are crunching.
That's
ChatGPT.
It's good.
ChatGPT wrote this to extract most money.
So yeah, maximizing profits. That's the idea. So this is the future of control systems. Let's go.
And then the last one I want to show you guys is George's.
All right, George has a solution too that we're gonna see
I
if we can
saw
stop.
some people holding the thing like this, like they were walking up against the left wall like this. So I shamelessly copied their strategy, and was like, with engineering prowess and existing knowledge of the comma code base, maybe I can win. It's open source right now on my GitHub under body loop. I also put it in speed mode for maximum entertainment. So we're going to see. We're just connecting to the body here. Let's go in.
Who's the first one to do that?
Yeah, so just here it is. It's, you know, it's called Common Body Loop Driver. I did all the training and inference in TinyGrad. The thing that I'm most proud of is that I have control.py, and control.py can run seamlessly either on the device or on the computer. And it'll loop it nicely on the computer, or it'll just run locally on the device. I didn't have to use TNID. I just used the TinyJIT. So I collected a data set. Yeah, I can just, maybe I'll show you like what the data set looks like.
It works. This is a 0.1 hertz.
So like this is an example of when you're too far to the right. You just recorded this data.
What labels do you have? Is just like left,
I just
right?
labeled the entire video. This is a right video. There's left videos and right videos. Here I can show you a left video. Can you switch it up? For comparison.
How many videos do you have in left and right?
So I gathered lots of videos, and then I actually got it to drive the entire loop once during the day and once at night. Every time it would mess up, I would just record a mess up video. So I can show you what these mess up videos look like. Like this is my data set here. So we can look at like mess up 1.
The mess up video is also going to be like one class, or?
Mess up videos are just one class. This is a mess up where you should be going more right. See? So like if it's over there, you should be going right. All right, let's see if this works.
So did you clip the mess ups to where they should have done something else?
Yeah.
Makes sense.
So I put it in maximum speed mode. We got to compile the model here.
This is kind of...
Whoa. Wow.
Very smooth.
So yeah, yeah, and then I made it to the winner's circle, man. Like they hooked me up. They liked what I did. You know, it helped that a lot of people weren't able to complete the course. It was really just me and the first place team. Thanks, guys. It was really just me. I got 3rd place. The first place team was the 2 French guys and the girl from Stanford. And these guys to the right, they inspired George's solution with a fully end-to-end solution where they gave him the idea to like paint the walls. They tried to do it themselves, but they weren't able to get it working as well as George was. So yeah, so they got 2nd, and then I got 3rd, man, as a low, which means I didn't have to split any of the prize money. So that was dope too. But yeah, so for next time, what I want to do is like, don't doubt myself, man. Like, yeah, I know these are big people from big institutions doing big things, but like, okay, I can compete, man. I can make this happen. And oh yeah, what I also want to do is dig into George's repo. So George made everything he did open source, published it to GitHub. So I've cloned the repo and I've taken a look at it. And you know, when I get some time, I'm hopefully in the new year, I'll get some time, because like all this stuff I'm doing is on evenings and weekends, man. I got a full-time job, so like, you know, so yeah, hopefully in the new year when I have all my like little other side projects wrapped up, I'll be able to spend some time and actually dig in and see how he did it and do it myself. And also, oh yeah, for my next hackathon, I want to spend more time on DevOps. You know, like don't be afraid to spend time on like getting the infrastructure and the tooling. And that is something that like I felt like I had nothing to contribute these other teams because I've never trained a model before. I didn't know how to do it. But you know, actually, like everyone you need all this DevOps stuff. You need to know, you need to be able to get your code onto the machine. You need to get it working. You need to figure out real-time communication. You need to get the device to take whatever your model gives you and turn that into a movement command. So, you know, there's more to do than just train the model, even though that's where it's lacking. And yeah, and I think let's see, yeah, that's what I got for you guys. So sorry, you know, I try and keep my talk short, but you know, as has been said by many people, I would have written you a shorter letter if I had more time. So if I had more time to prepare, this talk would have been like 20 minutes, man, a tight 20, and everything worked. But this is what I got. Thanks, everybody.
That was so cool. Can I raise my hand?
Oh, absolutely, absolutely. Yeah, Mark, what's up?
I think it's really super nice. I think you totally got out of your comfort zone there.
Oh yeah.
That's amazing, Mike. That's really amazing, and totally do it more often. You know.
Yeah.
Go out of your comfort zone, come back, go out, come back. You know, I think it's really useful, and it is required in our area, engineering. We need to keep learning, you know, and stuff. I think you cannot stuck, and to learn something new is always good, and you know, not just front end. And I would recommend you don't postpone your learning. You said in the new year, you have time.
Make time now. That's what you're saying.
Every day, like half an hour. Okay. Maybe
right. Okay.
You know, it's even better for the brain to kind of process that stuff. You know, I would not recommend to postpone it. You know, it's maybe tricky to chunk it down in smaller parts, which are kind of comprehensive. You know, those learnings. But I think if you do a little bit every day, that sums up over the year.
Yeah.
You know, totally. And as well, because it was like feeling like, I guess you call it a bit like imposter syndrome or whatever, when you are joining. I mean, like, keep always in mind you have like great expertise in other areas, you know, and it's always like you can provide great expertise in those areas, you know, like front end, really amazing expertise, and then you can get something back from other people, you know, learning more about DevOps, learning more about ML, you know, data engineering, and all that stuff. So I think that's kind of good to bring something in and give something back, you know. So so yeah, that's really great. That's really cool that you did that. And
Mark, you're so motivational, man. I appreciate that. Thanks, Oliver.
And that's actually like a super quality from you as well, you know. It's like you motivate people around you, you know, people feel comfortable. Yeah, totally brings that in, you know.
Thanks, brother.
No?
That means a lot to me. That means a lot. Thanks, Oliver.
Yeah, for sure.
I want to say something.
Yeah. What's up?
As a machine learning fanboy myself, and I've spent tons of hours trying to learn and gotten stuck the same time and again on mathematics. Shit, man, your solution was the very definition of being clever. That was amazing. I want to ask, I think now that I've been seeing this, I can tell that most of your Scrum chats have been about your preparation for this event. Like you brought up the Zork analogy 3 weeks ago.
Did I? Oh wow, yeah.
You made Aaron give a talk about computer vision and all of that planning for a great result. That was great, Mike. How did you? What did you actually use? Did you use the OpenCV stuff that Aaron showed us back then? Did you?
Yeah. So definitely, I had to have OpenCV. So OpenCV is that's what the YoLo model was sort of running with in tandem with. And so with OpenCV, you can parse these image files. And so with OpenCV, I could look at like where are the squares, like where was the person detected. And so with OpenCV, you do that, and I can iterate over the, you know, OpenCV just gives me a array of different elements. Each element is either a person or a plant or a computer. And so with that, I can then, you know, pull out like, are you a person? Okay, good. Are you the biggest person? Yes, you're what I want. Pull that out. and then tell the robot to target that.
And the Coma AI API must have been like, I don't know, move forward or rotate this much or go with the speed that way, that kind of stuff.
Yeah. Well, it's like you have like a channel A, which you give it a value between -1 and +1. So -1 means, you know, for channel A is forward. So if you give it a value of +1 to channel A, that's going to tell the wheels to go forward. And if you give it channel B a value of +1, it's going to fully rotate.
It's a control stick. It's holy. That's so great. That's so great.
They abstracted all the torque stuff away. It was great. It was like, I gotta give them credit, man. Their code base, you know. Okay, and this is why I've been pushing for let's use sub repos instead of GitHub packages, because sub modules. Yeah, because these guys use sub modules. I'm like, man, these guys have such a nice code base. If they're doing it, it's probably a good decision. So I kind of want to try it just to see.
For this kind of stuff, they're typically doing like if it's a ROS thing, the whole point of ROS, it was kind of like microservices before there were microservices. Like it's like the whole idea is the pub sub model, everything's federated, and most of that stuff actually, when you look at like a company, like a smaller robotics company, most of their software, even like ClearPath, where I work, we're using like a lot of the stuff that made up the whole SDK was just off the shelf ROS components, like open source stuff. That stuff's that, you know, you can just piece together like a ton of like little things like that and get like pretty high level functionality out of it.
Yeah, it's amazing how this whole pub sub thing inside the car, they do a similar sort of setup. In the car, you have a CAN bus, and everything is publishing to the CAN bus, and you can choose what you want to listen to from the CAN bus. And so that's how these things work, man. They hook themselves into the CAN bus of your car, and they're listening. You know, they're listening for what are the wheel rotation speeds, what is the current yoke or the current control state of the wheel and the gas and brake pedal, and then they can publish to that bus. They can tell the car, like, all right, I want you to apply some acceleration now. I want you to apply brake now. I want you to turn the wheel. It's cool how, you know, how you robotics guys have done this. How you've abstracted away all this communication into this pub sub model. I think it's so cool, man. Yeah, it's so cool.
Fun fact: CAN was invented by Bosch, where I used to work.
Oh, was it really? And what's amazing is not everyone had to adopt that, right? Like Ford could have come up with their own thing, and like BMW could come. Oh, did it at one point?
Yeah, but CAN has become basically the de facto standard.
Yeah, which is great, and yeah, it's you know, it's readable. Things aren't like things aren't encoded or not encoded is the wrong word. Encrypted. Things aren't encrypted, so you can communicate with different parts of the car, which is why they you know, the reverse engineering. Of course, they had to do a lot to reverse engineer the car to be able to make it self-driving. But and that's another thing that shocks me is that like these car OEMs, like they're not using, like, they could leverage this stuff, man. It's open source. They could fork it. They could work with it, you know. So
I'll tell you sometime how car stuff works.
Yeah, and that's
from like the you know,
the business side, right?
Business side, yeah.
Yeah, the guys with the suits and whatnot. Yeah.
All I can say is we're gonna have something that, you know, beyond cars before that.
Before they all move. Yeah. Before you solve those non-technical challenges. Gotcha. Yeah. Cool. All right. So anybody else got anything before we wrap it up?
If we're lucky, next year I'll be your partner, and we'll have Leon too.
Let's do it, man. Yeah, get that visa, man. Let's go. I'm definitely going back.
Wish me luck.
Yeah, definitely going back. Cool. That'll be fun. Okay, well, thanks everybody for the attention. Appreciate it.
Thank you, Mike. That was really good.
Thanks. It really was.
Thanks, guys. Appreciate it. Thanks for showing up. I love the audience. I'm glad I was able to share. All right, thanks everybody. See y'all at Scrum.